All right, welcome to the first of two lectures, part one and part two, on the social factors that influence the development of science. So as you recall, when we looked at the lessons from Thomas Kuhn's book on scientific revolutions, while Kuhn was criticized for many ideas, he did rightly point out that we should pay attention to the history and kind of social structure of science. And there were modest interpretations of his views as well as radical interpretations, and both had influenced later, understandings of the sociology of science and the social structure of science, as we will see in this lesson. So let's just dive right in. So just as a review, Thomas Kuhn had a famous incommensurability thesis. According to Thomas Kuhn, there is no common measure to evaluate competing paradigms because what the standards for a good paradigm are paradigm dependent. So what's a good theory according to one paradigm will be different from what is considered a good theory in a different paradigm. So Kuhn argues there's just no common measure. There's no common ground between competing theories to assess which one's better or worse. However, there's several different ways to interpret this. One is there is a soft interpretation of Kuhn, or like you call it, a modest interpretation. And yes, that's a very bad Photoshop of Thomas Kuhn in a Snuggie. Basically, we need to rethink what rationality is on this modest or soft interpretation of Kuhn. Basically, when pushed, Kuhn moderated his views and says there's just no algorithm to compare the merits of competing theories in distinct paradigms. What do we mean by that? Take one theory that's simple, broad in explanatory power, but imprecise. Take a second theory that's complex, broad in explanatory power, and precise. Which one's better? Well, this one, is simple, which is good, better than it be complex. But then this theory one's also imprecise, whereas theory two is precise. So it seems like this is a tie. But there are other examples where perhaps theory one is simple, theory two is simple, theory one is broad, theory two is broad, and theory one is imprecise, and theory two is precise. So it seems like in many cases there's like a clear-cut algorithm that you could apply to say that one theory is better than another. However, as Kuhn rightly pointed out, much progress or much change in the history of science didn't involve these simple algorithmic procedures, where, as you recall from my earlier lecture, an algorithm is a rule to determine, what's better than the other. And as I pointed out, there isn't this like one algorithm that you can use to assess all competing scientific claims. The reasons that Copernicanism is better than geocentrism are going to be different than the reasons that, for example, the germ theory of disease is a better theory than the humoral imbalance theory of disease. Okay, the reason Einstein's special theory of relativity is better than Newtonianism is different from the reasons that Darwin's account of variation through natural selection is better than earlier accounts. So yeah, there's just not just this one algorithm that we can apply to all scientific change and all competing scientific claims to assess them. It's just not that simple. The history of science is way more complicated than that. So Thomas Kuhn was right to point out that we don't compare theories using these algorithmic methods. So that's the modest interpretation of Kuhn, and that's something that most philosophers of science, including your instructor, Davis, think Thomas Kuhn got right, and based on the actual just progress in science and the history of science. So that's the modest interpretation of Kuhn, and all Kuhn was saying was, in this interpretation, is he kind of backpedaled and said, no, scientific change, I'm not saying it's not rational. I'm just saying that we need to redefine or rethink the definition of rationality. If we define rationality in terms of this kind of algorithm that's universally applied to competing scientific claims, and that's an inaccurate depiction of the history of science. So we need to think of an alternative definition of rationality other than this algorithmic view. So again, Kuhn was right about that. The rationality of science isn't basically the same thing as this algorithmic view. Okay. However, there was a hard interpretation of Kuhn that we looked at last week. And we're bringing this up because this influenced a lot of later thinkers and skeptics and deniers as well. On this hard interpretation of Kuhn, there is no rational basis to judge one paradigm is better than another. So it's irrational to claim that the germ theory of disease is a superior theory of disease than the humoral imbalance theory. It's irrational to claim that surgeons washing their hands and cleaning their surgical tools is a better way to prevent disease than, draining the blood of patients, which was the most common practice. So, and Thomas Kuhn also held that scientific evidence is impotent, okay? So, according to Kuhn, then you need to look at something other than scientific evidence to explain scientific change and why theories became popular. So, the germ theory of disease didn't become popular because of evidence of germs, from Louis Pasteur, Thomas Lister, and Robert Koch, and Ignaz Semmelweis. Instead, you have to look at other things. Well, what are those other things? What else other than the scientific evidence would there to be to look at? Well, in the 1960s and 70s, a group of sociologists had an answer to that, which we were going to assess. They wanted to replace the philosophy of science with a sociology of science. And they wanted to explain scientific change, not in terms of scientific evidence, like laboratory evidence that, against spontaneous generation, but instead social factors, peer pressure, cultural pressure, wanting to fit in. So these cultural studies thinkers, they push the idea that science is just one way of investigating the world, but it has no more authority than other ways. And now, this isn't the same thing as... Now, remember, when we looked at the lecture on philosophy and science, scientism claims that science is the only way to investigate the world. It's the most superior way. Now, we saw that there are problems with that because, science is laden with philosophical assumptions. But nonetheless, you can still claim that science is a superior way of investigating some claims than other ways, okay? For example, the germ theory of disease. The techniques of modern science are probably going to be more effective than, what you might hear on various internet forums. Perhaps astrology is not going to be as reliable a guide as to whether germs cause disease than, laboratory investigations, for example. So these later sociologists, and these are broadly just social thinkers. So this included historians, feminists, cultural anthropologists, and as well as some philosophers. They push for this very radical thesis that scientists actually construct knowledge, facts, and reality. That is, they argue that reality itself is socially constructed, okay? And if they're right, we live in the Matrix. So, let's talk a little bit about social constructions. Clearly, some things are socially constructed. Boundaries between states and between nations, that's socially constructed. The 7-day week is socially constructed. The names for the different days in the 7-day week are socially constructed. Trick question. Do you think the 4 seasons, winter, spring, summer, and fall, are socially constructed? I'd say less so. Given we know about the tilt of the Earth and its orbit around the sun, I'm pretty sure fall is different from spring. Okay, and it's not arbitrary. But, the 7-day week is. Boundaries are, look at that. It's just a straight line. That's totally arbitrary. Whereas West Virginia seems to have, who knows how that shape came about. And nonetheless, they're socially constructed. They're kind of made by human decisions. But they nonetheless impact our experiences on a day-to-day life. Whether you qualify for certain medical treatments, like the COVID-19 vaccine is in part due to decisions made by humans. Whether you qualify for welfare, whether you qualify for refugee status, whether you qualify for scholarships, okay? These are ways that have major impacts on someone's life. And in some sense, the decisions are, I guess you could say, and it's socially constructed. So a lot of the world that we encounter is socially constructed. Here's a more common example. Whether you drive on the left or right-handed side of the road, that's due to human decisions, okay? And I would say that's something that's also entirely arbitrary, okay? Britain and countries impacted by the Commonwealth could have all decided to drive on the left-hand side of the road. So these are arbitrary. These are socially constructed reasons. That's also completely arbitrary. Other reasons perhaps aren't arbitrary. Think again about COVID-19 vaccine distribution. Bioethicists influencing policy decided that they should vaccinate healthcare workers and the elderly first. They could have decided something else, but there were good reasons for that decision because obviously if you vaccinate the elderly, you dramatically reduce hospital admissions and fatalities. Okay. So granted, yeah, a lot of the world that we encounter is socially constructed. Some of these reasons are completely arbitrary. All of these reasons seem to impact our day-to-day life. However, according to these sociologists of science, you see right here, as well as a number of other thinkers, it isn't just, maps and boundaries and whether you get a scholarship or whether you drive on the left or right-hand side of the road. Those aren't the only things that are socially constructed. All of reality is socially constructed. For example, viruses, gravity, atoms. This is a startling conclusion. So gravity, that thing that, if you went to the top of the Fenwick Library, which I believe is 5 stories, and stepped off the roof, it seems like gravity would explain why you accelerate towards the ground and hit it very hard. But according to these sociologists of science, gravity is a social construction. Viruses, seems like they exist whether or not humans acknowledge them or not. According to these sociologists of science, viruses are a social construction. Atoms are social construction. This is obviously a very radical conclusion. So let's take a deeper look in it. Why do they hold that everything is a social construction? Well, according to these thinkers, we can't access a reality independent of our experiences. It's kind of like we're behind a veil, okay? Here you are. Here's your head. I'm not a very good artist. Perhaps all that you have access to are these kind of experiences, these internal sensory experiences that are inside here. And it's kind of like a veil. You can't get beyond this veil to the actual things that are kind of causing these experiences. Like suppose you see a dog. Here's my drawing of a dog. Here's the tail. So you have an experience of a dog, but you can't access the actual dog. You can only access the experience of the dog. So we're getting into some deep stuff right here. But perhaps that's why. So then, according to these sociologists, the only meaningful things you can say about reality are constructed from the ideas you get from reality. Like, you cannot talk about the dog. You can only talk about your experience of the dog. But you can't talk about the actual dog itself. Okay? Now, we won't go into too much more depth on this. If you ever do want to learn more about this, take Intro to Philosophy with me, Dr. Davis Kirkendall, and we will spend quite a bit of time talking about this topic. So here's the problem, though. There are theories and there are ideas, and there are what the theories and ideas represent. Of course, theories and ideas are socially constructed. But what theories and ideas represent are not socially constructed. What do I mean by that? Let's take a look at an example. Here are various words for fire from various languages. English, German, Latin, Spanish, and so on. The symbols, the strings of symbols that symbolize fire are socially constructed. We could in English spell fire like this. It's completely arbitrary that we decided to spell it this way instead. So the symbols in language for fire are socially constructed. I am not disputing that. That's a basic fact of human language. Human language is socially constructed. But all of these symbols, which are all socially constructed, they represent something that is not socially constructed. Actual fires. Here's a startling image from the wildfires that were ravaging the West Coast last year. The fires that were ravaging the West Coast were not socially constructed. If you don't believe me, go talk to someone from California about what they are experiencing. Go look at the corpses of various wildlife that were tragically killed by it. Okay. So again, what is socially constructed represents what is not socially constructed. Obviously, this is socially constructed, but that doesn't mean that reality is socially constructed. Forest fires while they might be caused by humans, they're not social constructions themselves. Okay. So we need to recognize a distinction between what represents and what is represented. This is a drawing of a horse. This is a horse. This is representing that. This is socially constructed. That is not. Reality, so just because what represents reality is socially constructed, it does not follow that reality itself is socially constructed. So this argument right here is a non sequitur. It's fallacious. Premise 2, the conclusion does not follow from premise 1. It's true that what represents reality is socially constructed. That is true. But 1 can be true. That does not mean that 2 is true. It's possible that 1 is true and 2 is false. And I'm going to submit that 2 is false. I'm sorry, but germs are not socially constructed. Gravity is not socially constructed. Atoms are not socially constructed. The planet Mars is not socially constructed. And so on, etc. So going back though, these advocates of the strong program in sociology of science, who were clearly heavily influenced by Thomas Kuhn, they were what we call relativists. And according to them, the popularity of scientific ideas and scientific change itself is explained solely by social factors. So why do they argue that scientific change is explained solely by scientific factors? It's not explained by evidence, it's explained by social factors. Well, they defended what is known as the symmetry principle. They held that the same type of explanation for the adoption of beliefs should be applied to every community. Okay, should explain why scientists believe something the same reason you explain why, religious people believe something, and the same reason why kids believe something, and so on. Here's an illustration. Here's an example. My Aunt Frida believes that 5G cell phone networks are what cause her vertigo. Coincidentally, she only gets vertigo after she's had her 4th or 5th mojito. But setting that aside, take some scientist beliefs instead. Scientists believe that water is H2O, for example. Proteins are sequences of amino acids. Uranium-235 is fissile, while uranium-235 is not. Well, according to the symmetry principle, you should give the same explanation for my Aunt Frida's beliefs that 5G causes her vertigo that you would give for scientists' beliefs that, water is H2O, and so on. Or maybe to flip things around, the same type of explanation that you give for Aunt Frida's beliefs should also be applied to scientists. So, there's nothing special about why scientists believe what they believe compared to, I guess you could say, non-scientists. All sets of beliefs have the same explanation according to these cultural theorists, these sociologists of science and related cultural theorists. Which, recall going back to the first week, don't we think there's something special about science? It's authoritative, its methods are reliable compared to other fields. Well, if these cultural theorists are right, the answer would be no. So why do scientists believe that water is H2O? Is it because they have a wealth of evidence that water is H2O? According to the sociologists of science, no. It's explaining a scientist's belief that water is H2O by appealing to the fact that water is H2O. That violates the symmetry principle. Because again, you have to explain, all explanations of beliefs have the same type of explanation. It's in terms of social or cultural factors, not rational evidence. So this is relativism. According to the strong program in sociology, then, scientists adopt some standards of evidence. Other communities adopt different standards of evidence. So, for example, Jan, a molecular biology PhD student, believes that humans should incorporate a healthy balance of all macromolecules in their diet, based on her laboratory studies. Her sister, Fran, an Instagram influencer, recently decided to go on a diet where she only eats mangoes because her goat yoga instructor read somewhere on the internet that it's better for her well-being. According to the symmetry principle, no standard of evidence is better or worse. You might find this troubling or flawed or problematic, and if so, you're not alone. there are criticisms of the strong program in sociology of science, as well as especially their symmetry principle and their relativism. So again, here's one criticism, and I think this is probably the most fatal one. The strong program in sociology of science, which was advocating for the symmetry principle and relativism, well, they assumed that their methods were authoritative, superior, and rational. So they did not assume that their methods were equal to every other method. They assumed that their methods were authoritative and superior and rational. Recall that according to the strong program in sociology, however, that no standard of evidence is better or worse. So on the one hand, no standard of evidence is better or worse. On the other hand, the strong program in sociology of science assumed that their methods, their evidence, their conclusions were better than everyone else. That's self-defeating. My favorite GIF file, it's sawing off the branch of the tree you're sitting on. Oops. Well, there's been other challenges to the rationality of science, influenced in part by Kuhn. And we're going to spend some time in what was known as the underdetermination of scientific theories problem. What do I mean by that? So look at this. Suppose you're playing a game, like Hangman. You've got 6 letters, and you know that the 4th letter is L and the 5th letter is N. Well, this information is consistent with more than one answer. It could be Dublin, it could be Berlin, if you know it's a city in Europe. Because, hey, look at that. Okay, so that's an example where the evidence underdetermines the answer. You have more than one conclusion that's consistent with the evidence you currently have. Therefore, the evidence underdetermines any conclusion you might draw. We find this in scientific context sometimes. So suppose all you have is 4 data points. Like perhaps this could be temperature trends. And all you know is that on these 4 data points, the temperature goes up. Well, that's consistent with a linear interpretation of the data, parabolic, or nonlinear. I mean, it could be that, the temperature was up here between 1 and 2. And it was up here between 3 and 4. And then it was down here between 3 and 4. Suppose this is like temperature data for the Arctic Ocean. In which case, you could say that this evidence underdetermines the trajectory. You would need to get more data points. Like you need to take temperature trends here and here. So, this is a problem that we find in some scientific theories, including ones where we experience a lot of denialism and skepticism. So is this a challenge then to the rationality of science? Because the deal is a lot of scientific information is actually consistent with more than one explanation. Well, sociologists of science in the 1970s argue that this underdetermination is the reason to replace the philosophy of science with a sociology of science. And basically, you replace explanations of scientific beliefs in terms of evidence with explanations of scientific beliefs in terms of non-rational factors. Going back to this, pretending like this was temperature data for the Arctic. Suppose that you favor this interpretation, the linear. Well, it could be the case that you favor that instead of my wild lines because you're a climate change affirmer and that you have social pressure to push for anthropogenic climate change. So it's political or social or peer pressure factors that cause you to favor this linear interpretation where you think the best explanation for these 4 data points is this kind of linear upward trajectory. So that's a non-rational factor then. So the problem of underdetermination, it's a hard word to say. Underdetermination. Let's see how many syllables that is. 1, 2. And I even misspelled it too. Oops. I don't qualify for my job. Undetermination. Go ahead and Photoshop it. Go ahead and take a screenshot of this and send it somewhere. The professor who can't spell. I don't care. I ran out of coffee this morning, so I'm kind of out of it. That's a lot of syllables. Anyways, Pierre Duhem was the first person to draw attention to the problem of underdetermination of many scientific claims by the available evidence. And he asked us to consider a prediction that yields an observation that is inconsistent with the hypothesis. Let's just give it. Well, according to appeared to him, there's no straightforward answer on whether we should just say that the hypothesis is false, or whether we had a faulty experimental setup, or whether perhaps there was a confounding variable. So you stats kids should be familiar with that by now. So let's just give an example of confounding variables. Suppose that you were to conduct a study assessing how alcohol consumption impacts dancing abilities. That is, you want to find out if alcohol consumption improves or impairs someone's dancing ability. Well, here's your hypothesis. Your hypothesis is that alcohol makes people dance worse. Okay? So you design an experiment where half of the participants consume large quantities of alcohol. Now, these are young college kids, but you also include all ages, including keg stand to granny. The other half, on the other hand, only drinks skim milk. What are the results? Here are the skim milk dancers. Here are the skim milk drinkers. Okay. That's bad. That's some terrible dancing. So we know that skim milk from this sample does not seem to make someone a very good dancer. Now let's look at the dancers who drank lots of alcohol. Okay, that's way better. So it seems like the alcohol drinkers are clearly better dancers. Does that challenge your hypothesis that alcohol impairs someone's dancing ability? That is, do you reject the hypothesis that alcohol impairs dancing ability? Well, all you who took Honors 110 should be like, wait a minute. Maybe there's other factor that could explain it, a confounding variable. Like maybe the drunk dancers also had professional training. Maybe they had better sleep the night before. Maybe they had also consumed caffeine. So we don't actually know from this alone whether or not alcohol impairs dancing ability. There's other explanations available. So you shouldn't necessarily reject this hypothesis. That's an example of the underdetermination of a kind of a scientific claim by the available evidence. We have several different explanations that are consistent with the data that we do have. Another thinker, Quine, Willard Quine, argued that all our beliefs are tested against experience when any of our beliefs are tested. So anytime you make a statement, any crazy statement out there you can make true as long as you tinker with beliefs elsewhere in your kind of network of beliefs. So then even beliefs about math and logic could be revised. Okay? So let's take a look at an example of what Quine means by this, because this is some fairly abstract stuff. But before we look at that, an implication is that additional empirical data could not settle scientific disputes. Something other than the evidence would settle disputes, like human psychology or cultural factors or political pressure. So basically, if you believe that my hypothesis that alcohol impairs dancing ability is false, it's due to versus one of these other explanations, like they had better training or better sleep or consumed alcohol. According to Quine, it could be going to kind of skeptics of scientific progress. It's cultural factors that explain this skepticism. An objection you might raise, though, is aren't some explanations just more plausible than others? I mean, you don't believe it because of cultural pressure or peer pressure. It's because it's just a better explanation. Well, let's take a look at an example. Suppose you have this one point of data. You have a roommate and your roommate is not at home. Instead, your roommate is at work. That's a hypothesis. You hypothesize that your roommate is at work. But there's another explanation out there. Perhaps your roommate was abducted by aliens. So which hypothesis is better? Isn't hypothesis 1 more plausible, that your roommate is at work? And most people say yes. Here's why. It could be that hypothesis 2 is true as well, but a whole lot of other beliefs that you have would have to be changed and revised. Like suddenly you'd have to believe in aliens and that they've been to Earth. And that not only have they been to Earth, but they've decided to abduct, of all the humans on Earth, your roommate. In this particular occasion. Okay? So you'd have to tweak a lot of beliefs that you already have. You'd have to revise a lot of things you believe to make hypothesis 2 plausible. Whereas with hypothesis 1, you don't really have to change a whole lot. Your roommate has a job. Your roommate's not home. Your roommate's probably at work then. Okay? So isn't hypothesis 1 then more plausible? Because it's just simpler. It's easier to believe, right? Well, here's the deal. Why is hypothesis 1 more plausible? Why is simplicity better? Quine says there's no rational reason to prefer simpler beliefs. We do. It's a psychological fact that we prefer simpler beliefs because they require way less of a disruption to our previous beliefs. But that's not a rational reason. It's easier. We like simpler beliefs because they're easier. You don't have to tweak a whole lot to believe that your roommate's at work, but you have to change a bunch of other stuff in your beliefs to make it plausible that your roommate was abducted by aliens. But again, that's not a rational reason to prefer hypothesis 1 to hypothesis 2. It's just easy, and you're lazy. According to Quine, the only reason you believe hypothesis 1 is because, not because you're rational, it's because you're lazy. You're just lazy. And all humans are lazy. Well, that's a problem. That's a big problem. So let's take a look. But Quine and Pierre Duhem, we need to be a bit more precise. We need to distinguish because there's several different types of underdetermination. There's global underdetermination, there's local, and there's transient. Let's take a look at each in turn and assess how that impacts the rationality of science. Let's take a look at global underdetermination first. So there are competing theories that make the same predictions about anything we can observe. And these competing theories are completely indistinguishable with respect to their empirical consequences. Let's just give an example. So global underdetermination is a type of radical skepticism. So imagine that you're a brain in a vat that's getting fed sensory information so that it seems like you have a body and you're moving about in the world, okay? So just imagine you're actually a brain in a vat connected to a very sophisticated computer network, and it seems like you're in the world. It's like you're dreaming, okay? That's radical. So that's it's called a brain in a vat skeptical scenario. How could you know if you're a brain in a vat? Well, let me ask you this. Yeah, how would you prove that you're not a brain in a vat? Could you prove that you're not a brain in a vat? Because it seems like everything you perceive, everything you see, smell, hear, touch, taste, is just due to sensory information plugged into you from a very sophisticated computer. Perhaps you can't prove you're not a brain in a vat. Perhaps you can't. The fact is, it may be that no observation could determine if you're a brain in a vat or a full-bodied human in the world. Well, this is an example of underdetermination. Everything you perceive is consistent with you actually having a body, but is also consistent with you being a brain in a vat that's being fed sensory information. So the evidence you have from sensory experiences underdetermines whether you're a brain in a vat or you actually have a body. And it's true, you could be a brain in a vat. It's also true that there could be theories, unlike current ones, which have the same empirical consequences. However, here's the deal. Once you start doubting all assumptions, you enter the realm of radical skepticism. Be that as it may, radical skepticism, or global underdetermination, it's irrelevant to particular local scientific claims, such as whether HIV causes AIDS, whether flu shots effectively reduce your chances of getting influenza, whether CO2 and methane are greenhouse gases. So that doesn't give me a reason to disbelieve it. In fact, it would take a conspiracy of matrix-like proportions to doubt the particular claim that viruses cause illnesses. Like saying, I don't believe viruses cause illnesses because I'm a brain in a vat. It's possible that I'm a brain in a vat, therefore viruses don't cause illness. That's just not a very plausible argument. So global underdetermination doesn't seem like a very good challenge to like particular scientific claims like global warming, how viruses spread, and so on. Of course, that won't convince everyone, but so what? So now let's take a look at a different type of underdetermination. It's called local underdetermination. So let me ask you a question. Did Neil Armstrong scatter the cremated remains of his pet cat Nibbles on the moon? Do you know that for a fact? Here's the deal. We don't know if Neil Armstrong scattered the ashes of his deceased pet cat on the moon. It may be that Buzz Aldrin, the other guy that landed on the moon, that walked on the moon, who's still alive today, doesn't know either. It could have been that Neil kept it to himself, didn't tell his wife, his kids, or anyone. He just secretly brought some ashes and then scattered it when no one was looking. Does the fact, though, that you don't know that, does that mean that you can't know anything else about Neil Armstrong? No. Okay, we don't know whether he scattered the ashes of his pet cat on the moon. That doesn't mean that we can't know a whole lot else about Neil Armstrong, like he landed on the moon. He was an astronaut. He went to Purdue University in Indiana, like me. And yes, I'm wearing a Canadian tuxedo. Go ahead and make fun. I don't care. Many facts about Neil Armstrong are not underdetermined. Okay? So the fact that we don't know one thing doesn't mean that we can't know a whole lot of other things. Okay? And a lot of science is like that as well. There are some things that we don't know and may not be able to know. But that doesn't mean that there's a lot of things that we do know or could know. Okay? So that's not a reason to be skeptical about like all of science. So local underdetermination then involves a small number of claims within a more general scientific theory. And these small claims are not settled by available evidence. So there's some wiggle room within the broader set of beliefs that we assume are not underdetermined. And it's not irrational to withhold belief in cases of local underdetermination. It's not irrational to withhold belief on whether or not Neil Armstrong scattered the cremated remains of nibbles on the moon. It's probably rational to not believe it, to withhold belief. Okay? But that doesn't mean it's irrational to withhold belief about, like, whether or not Neil Armstrong was on the moon. That is irrational to withhold belief on. So local underdetermination then does not pose a challenge to scientific authority. Lastly, let's take a look at what's called transient underdetermination. So sometimes there are cases where the theories or hypotheses generate alternative predictions, and we are so far unable to decide between them due to the currently available empirical evidence. Again, this is also not a threat. The sensible course of action in these cases is just to do more research and hope you find data later that settles the dispute. Let's take a look at another example. So perhaps there's a new virus. Virologists don't know the zoonotic origins of the new virus, okay? They don't know if it came from a monkey or from a pig or from a bat. However, not currently knowing the zoonotic origins doesn't mean that it can't know a whole lot of other stuff about the virus, like whether it's harmful to humans. They probably already know that. For example, this is a stomach virus. It also doesn't mean that they could not possibly find out later, after doing more research, what the zoonotic origins of the virus are. And yes, they could. They could do genomic analysis. They could do some field research. Take some blood samples from various animals. And they do, and they find out that it actually has its origins from a bat. Specifically a Batman. Oh crap, that's a dorky Batman. Is that me in a Batman costume? No, because I can't grow a mustache like that. Would that be me in a Batman costume? You'll just have to wait. Okay, so what's the takeaway then? If you're going to reject the results of a particular scientific claim, you need reasons that are relevant to that particular claim rather than global reasons, okay? Well, there's another skeptical argument I want to consider. That might help out the sociologists of science. Maybe science is irrational after all. So here's the deal. History is a graveyard of abandoned theories and methods, ideas, and attitudes. This is phrenology, an old belief about personality that said the shape of your skull determines your personality. It's been debunked. The shape of your skull does not really determine your personality. This was the ancient medical technique of bloodletting, where if you have a disease, you should just drain your blood and rebalance the humors in your body. This was the psychologist and behaviorist B.F. Skinner's kid in a Skinner box who believed that the best way to raise kids is the same way you train pigeons. That has also been debunked. Be glad you were not raised in a Skinner box like Skinner's son was. All right. Here's the deal, though. So many theories in the history of science have been abandoned. Why believe any of today's theories then? Who knows, maybe the germ theory of disease will be abandoned. Maybe you should just stop washing your hands. Well, it's true. Some scientific investigations will result in the modification or abandonment of some currently existing scientific theories. But is that a reason to doubt all theories? Let's take a look at an example. So in the 1970s, it was claimed that climate scientists thought that not that the Earth was warming, but that it was cooling. Here's some headlines. There is some truth to that. Volcanoes release sulfates, and sulfates do lead to cooling. And then a lot of factory pollution at the time also released lots of sulfates in the air, which did lead to some cooling. But at the same time, we're also still emitting tons of greenhouse gases like CO2 and methane, and that definitely leads to warming. So they were wrong then. Why believe them now? They were wrong when they said the Earth was cooling. Why believe them now when they say it's warming? Well, two things. Actually, even back then, most scientists thought the Earth was warming. If they did an analysis of all the peer-reviewed papers, and it turns out the talking point from climate change deniers that they used to believe the Earth was cooling is not accurate. Most of them thought the Earth was warming, and especially now. But even going back to 1965, the majority of them thought the Earth was warming. Second point is they've learned a lot since then. So, but how do you balance the authority of science with the dynamicity of, that's a hard word, dynamicity of science? The fact that science is constantly changing. It's authoritative, but it's also constantly updating our beliefs. Wasn't the coronavirus spread by surface contamination? Remember back in March when, they said that it could survive on the gas station pumps for up to 3 days, and people were scared to touch anything outside? Well, now they're saying it's not really spread by surface contamination. It's primarily person to person. So how do we take scientists to be authoritative? Well, it's because they learned more since then, right? They did more studies. They learned that it's isn't that how science works? But still, how do you maintain this balance? We want science to be authoritative, but it's also constantly changing. Well, scientific realists hold that the world is accurately described by most of our theories. Anti-realists claim that it might be useful to believe theories, but that doesn't give a reason to suppose that what the theories say exists actually exists, like atoms and viruses. Well, why believe scientific realism? Why believe that the world is accurately described by our current theories? In which case you should believe them, in which case they're authoritative. Why believe that? A famous argument is called the miracle argument. Science and technology have progressed a lot. 100 years ago, people were on horses and buggies. More like 120 years ago. Now we're in space. So we went by traveling by horses very short distances to we're in space. We have spaceships that go to the moon and Mars. Well, according to scientific realists, the best explanation for the progress of science and technology is that our current theories actually accurately represent what they describe. If they say there are quarks and electrons, there are quarks and electrons. If they say there are germs, there are germs. According to these scientific realists, it would be a miracle if our best scientific theories weren't at least approximately true. It'd be like the parting of the Red Sea. However, skeptics have a response to the miracle argument. The fact is, many discredited theories appeared successful by our current standards, but they're not even approximately true today. For a long time, our best scientific evidence said that the Earth was the center of the universe. After all, we see things moving around us in the sky, but we don't see the Earth moving. Now we know that's not even approximately true. This is so far off the mark. Someone that believes this should be ridiculed and shamed, tarred and feathered and shunned. Not necessarily, that'd be mean. That's wrong, I shouldn't say that. But, it's clearly a ridiculous belief now in 2020, even though it was a very plausible, rational belief in, 1430. So, the realist, though, has a response to that. The deal is, past theories actually were not as successful as the skeptics claim. Also, the rejection of past science actually doesn't challenge current science, because the fact is, current science is held to much more rigorous standards of evaluation today than it was back in the day, a long time ago. Science has grown exponentially. We have way more scientists today, more publications, more interdisciplinary work, more exacting standards. In fact, 80% of scientific work has been done since 1950. Okay. The majority of scientific work done in human history has only been done in the past 70 years, which is a very short time window. Therefore, it's flawed to predict anything about the future success of science based on its past record, okay? It's just, you should not infer anything about the future based on that. You should infer that the germ theory of disease might be debunked in the future just because the humoral theory and balance theory of disease was debunked 100 years ago. Because the evidence for the germ theory of disease is way more precise, rigorous, and there's just a lot more of it in terms of quantity. Here's a mind-blowing fact. Are you ready for it? I'm going to tell you a mind-blowing fact. The present is not like the past. Shocked! I know. Here's the deal. History records not just radical continuities, like scientific revolutions, like the Earth orbits the sun idea, the germ theory of disease idea. But there's also a lot of continuity and stability. We actually have a lot of permanent knowledge from the laboratory sciences. And we also have a lot of history of science that shows corrections to prior approaches and technological developments. Our theories and models agree with observations more and more these days, okay? You've probably heard this from your uncle. The scientists can't even predict if it's going to rain next July. Why should I get a vaccine? The weatherman can't even tell me if it's going to rain on Saturday when I go play golf. But going back to this point, we have theories and models today that agree with observations way more than they did in the past. For example, in the 1970s, here's an example from hurricane forecasting. In the 1970s, the projected position of a hurricane 3 days in the future was usually off by 440 miles. 440 miles. It's a full day of drivings. That's how far off it was. Now, it's only off by 173 miles. So they can accurately predict the path of a hurricane by almost a third of what they used to. That's way more precise. Their observations agree with models way more than they did 30, 40 years ago. Okay, so that's evidence that science in this domain in meteorology has gotten way more accurate and way better. And it is a reason to believe that current theories are better than past theories. And current technology is better than past technology. Okay, and there's lots of examples of this. So the fact is, history does not actually weaken the evidence that our current theories are better than previous ones. In fact, history provides evidence that our current theories are better than previous ones. For example, in hurricane forecasting. So arguing that all science is fallible does not give us a convincing reason to doubt a particular claim. For example, they used to believe that the Earth was the center of the universe. Therefore, why should I believe scientists that smoking is harmful? No, that's fallacious. That's a non sequitur. That's irrational to make that inference. Okay, that's it. So tune in for part 2. Bye.